Welcome to the second lecture of week 6 on financial mathematics for actuaries. This is lecture 27, and in this particular lecture we are going to discuss an interesting topic called decreasing annuities. We have already seen in lecture 26 how increasing annuities operate. So let us bring the context from lecture 26, and we are seeing when we are increasing the annuities, we start small and we grow large. In general, the examples come from salaries and inflation. However, there are some cases where people start large and then they slip down. That means they shrink to the zero level. Initially, you pay in large amounts and then reduce the number of payments. So this is what the main topic of today's lecture is. So use cases come from depreciating asset revenue, or you want to pay off your loans aggressively. In that case, it's reducing balance loans problem. So all these are typical use cases of our today's subject, today's topic. Okay. So let us design a roadmap for studying this today's topic. First, we will visualize this as we visualize the increasing staircase, we will visualize this as a descending staircase. Once we have understood the descending staircase, we will explore the symmetry between descending and ascending staircases. So we will derive the formula using rectangle trick. Basically, we will try to exploit the symmetry between ascent and descent, and then we will connect this particular descending staircase with our general PQ formula. And then once we have developed the framework, it is time to apply. So we will apply it for reducing the balance loan. Reference mapping as usual are Brouwermans section 2.3 and Chan and Say section 2.6. Let us begin our journey by visualizing the descending staircase. So when we have increasing annuities, we were increasing from 1 to n. Okay, so in the first payment was 1, second payment was 2, and so on up to n. So in this case, the first payment was 1, 2, 3, 4, 5, because this was an annuity for 5. What will be the corresponding decreasing annuity? Right. So that is the question, natural question. So if you want to replicate this into decreasing annuity, you will simply flip the side. The first payment will be 5, second payment will be 4, and third payment will be 3, the fourth payment will be 2 and 1. So that makes a rectangle, right, a perfect rectangle. And you look at each column, which is time period 1, what is the sum of these columns? So all of them are summing to n plus 1, right. So the height of all of them is n plus 1, it is a constant height. So this is something like level annuity, right. So this is something like level annuity. What is the amount that we are looking at is basically whatever is the height of this column. So what is the height of column? It is n plus 1, right. So we are looking at a level annuity of amount n plus 1. So can we use this knowledge to derive formula for our decreasing annuities? The answer is very well. I can use this formula and I can do it in a very simple manner. For example, whatever this visual display that we have given, it tells you that increasing annuities plus decreasing annuities for nth period is equal to n plus 1 multiplied by annuity at nth period. Okay, so this is the very clear understanding. If this understanding is clear, then what will be the formula for DAN? I already have the formula for IAN, IA angle n. So I will simply rearrange the terms and I will get this n plus 1 times A angle n minus IA angle n. Okay, and then if I substitute that formula, I should get back the formula for DAN. So let us do that as one simple exercise. So what I have n plus 1 AN. So what I will do, I will simply substitute this formula for increasing annuities, and that will give me say n plus 1 times A angle n as it is, minus, what is the formula for this? It is A double dot angle n minus n v raised to n upon I. Okay. So now I have this formula. It will require some time to understand this, but this particular thing is in annuity immediate, this is in annuity due, that is not a good way to handle it. So I have to convert this A double dot n into annuity immediate. So do I know the relationship between A double dot n and A angle n? Yes, I do know the relationship. What is the relationship between A double dot n and A angle n? Because if you do not remember, you can use your common sense. This is the beginning of the period, this is the end of the period. So this thing will be multiplied with 1 plus I. Therefore, I know that this particular thing will be multiplied with 1 plus I. So I will use that relationship and I will push in this I will push in the factor of I into the numerator of the first term. So angle n minus this particular thing is 1 plus I times A angle n minus n v raised to n, the whole thing upon I. Okay. So now now the field is set, I have to just do the algebra and get the answer. Okay. So what you can see is this 1 I A n and this I A n, both of them will cancel themselves off. Okay. So what I will get as a clean playground is this A n, which is not cancelling. So minus A n I will push out from this particular factor. Then I will try to handle this n A n, n I A angle n, and this I A n will cancel itself off with this I A n. So I do not have to worry about that. So A n terms are done. Then I have minus n v raised to n upon I, right. So in these two terms I can see that this n factor is common. So I will just take away that n factor and I will, for convenience, I will write it here. So this minus A angle n is retained as it is. I have taken a factor of n as a common factor. Then I have I A angle n minus n, minus v raised to n. Why is it minus? It should be plus. Okay, so it should be plus. Okay, so this is also plus, and then I have factor of I. Okay, now I will look at this A angle n. What is, do I know the formula for A angle n? I know the formula for A angle n to be 1 minus v raised to n upon I, right. So I will use this formula in the next step. If I substitute this 1 minus v raised to n upon I, this I will get cancelled off. So I have minus A angle n plus n, I will be cancelled with this I, and 1 minus v raised to n will survive. So it is 1 minus v raised to n plus v raised to n upon I, whole thing upon I. So what will this give me? This gets cancelled off. So it is n minus A angle n upon I, right. Is that what we will get? Yes, that is what we will get. So let us see this in a neatly written form, that is the formula. If I substitute this A double dot n and do some algebra, I get the formula for decreasing annuities as n minus A n upon I. However, This is the formula. So you can remember this formula. However, when you are trying to solve the problem, this formula may be rarely useful. What you need is that PQ method that we deployed, right? So let us now revisit that PQ method and understand how will this formula change. So if you recollect from that PQ method, our formula was somewhat different. It was not annuity due, it was annuity immediate that was playing a role. So how will this differ? So here there is a nice trick. If I have decreasing annuity, I will take this Q to be a negative number. If I do that, then it's very simple. So I will illustrate this with one use case. If Q is taken as a negative number, then basically in this case, in the example, we have payments of 10 and then Q is taken as -1, then 10, 9, 8, 7, 6 up to 1 for 10 years, right. So that is how we are decreasing the amount. So we essentially do not have to rederive the formula for decreasing annuities. If in general this Q is coming different from P, then I can simply use the increasing annuity formula and calculate the regular expression by taking Q to be negative, right. So once we have understood this framework, let us try to solve one example of depreciating revenue. So the problem here is a machine generates $5,000 in a year. The revenue of the machine drops by $500 each year. The term is 10 years, interest rate is 6%. You are asked to find the present value of this. Okay. So what are the parameters? This is definitely not P is equal to Q case. So we have to rely on our PQ method, which is 5,000. P is 5,000, Q is -500, the period is 10 and interest rate is 6%. All the information given, what do I need to compute? I need to compute annuity of 10 years for 6% and then apply the level part and the other part, which is decreasing part. So first level part 5,000, annuity 10 for 6%. Very easy, 1 minus V raised to n. What is V here? 1 upon 1.06 raised to 10 minus 10, right. 1.06 raised to minus 10 upon I 0.06. You will get the answer to be 7.3601 and therefore the level part will have the present value of 36,850. Let us look at the increasing part or a decreasing part, whatever you say. So we need A10 for that, A10 6%, NV raised to n for that, V is 1.0, V is 1 upon 1.06, so V raised to n is 1.06 raised to minus 10 and then you simply calculate using algebra, it turns out to be 29.60. Now this particular part you have to multiply with minus 500, that is the important thing. Okay, when you multiply this with minus 500, you get the final answer to be equal to 21,999.16. You check for yourself whether you are getting this answer. Okay, once you have done this, I have one exercise for you, which is the loan payoff problem, and it is part of our active learning. If you are borrowing a money, you want to pay it off aggressively. This is reducing the balance loan, right. In month 1 you are paying 600, in month 2 you are paying 590 and you are decreasing by $10 each month. How long the payment will last? It will last for 60 months, which is 5 years, right. The interest rate that is given to you is 12% nominal compounded monthly. I am making it very simple for you. This is 1% effective interest rate that you have to work on. Okay, how much can you borrow? Here the trick is, I have given you everything in months and I have given you everything in, I have derived everything in years. So you have to use your common sense and solve the problem. Okay. Welcome back. So, let us look at the solution of this problem. First of all, I hope all of you have identified that this is a pure decreasing annuity which is scaled at $10. So, P is equal to Q is equal to 10. Okay. So, this is what we have understood. So, it is a factor of $10. So, I can simply directly use the decreasing annuity formula on a monthly basis, right. So, interest rate becomes 1% monthly. And the time period is calculated in months. So, there are 60 months, interest rate is 1%, I can easily use the factor of 10. Therefore, my symbol or the calculation that I have to do is for DA 60 1%. You can simply solve this problem using that. Let us see the solution of the problem. Here you identify the pattern that this is a pure decreasing annuity which is scaled by $10. So, first payment is 60 into 10, second payment is 59 into 10, and this goes on till you pay the last for $10, right. So, inputs will be 60 months which is the time period. Interest rate, this is where 1% effective interest rate will get activated, and the decrease that is happening is by $10, right. So, that is the factor that we are interested in. So, whenever I am calculating this decreasing annuities, I will multiply this factor of 10 with decreasing annuity. Therefore, the symbol is 10 times DA 61%. So, just simply calculate this, so it is N minus AN, A angle N upon the interest rate, right. That is the simple formula that we have. Just calculate it, it becomes 44.955. Once I have this formula, I will push this into DA 60 and then I will get the number to be 1504.5, and then finally I will multiply this with the factor of 10. So, to get the value, present value of the money, right. So, we have done decreasing annuities. Let us summarize what are the important formulas and things that you need to remember. So, here are the things. First, we have decreasing annuity, that means you have payments which are n minus 1 so on up to period up to unit of 1. First payment is n, second payment is n minus 1, and these payments will continue until you get last payment of $1, correct. So, this is the decreasing annuity formulation. Formula for that is an elegant formula, n minus A angle n, which is the annuity immediate after n periods upon I. The relation that we explored is increasing annuity and decreasing annuity for n period. If you sum them up, you will get n plus 1 in times level annuity for n periods. We can use general PQ formula by replacing Q to be a negative number. Okay. Next, we will study the geometric annuities which are inflation adjusted payments. Thank you.